This video is all about the individual building blocks that make up proteins. Now, before we talk about proteins, I want you to think about if you need to build a house, what it is that you'd need. So to build a house, you need to start with individual bricks. And this is how you should think of biological molecules like proteins, carbohydrates and lipids. So thinking about proteins then, if we want to build a protein, we need bricks. Now in biology we call these building blocks, these bricks, monomers. And for proteins specifically, the bricks, the individual monomer units that we need to make a protein are called amino acids. Now, some basic things that you need to know about amino acids. First of all, we can categorise them as organic molecules because they contain the elements carbon, hydrogen, oxygen and nitrogen. Now this is really important to remember. In an exam, if they ask you to name the elements that make up amino acids or proteins, it's really important that you don't use the chemical symbols like I've used here. These are chemical symbols and they're not names, so you'd have to write out carbon, hydrogen, oxygen and nitrogen in full. So a little exam tip there. Now there are 20 different types of amino acids, and as we've just said, they're the monomers, the individual units that can be put together to make proteins. Now you need to know how to draw an amino acid. So, thinking back to when you first learnt to draw a person. So you draw a head up here, and a body with arms coming out at the middle and legs at the bottom. Now, it sounds really, really silly, but how did you learn that that was how to draw a person? It seems silly now, doesn't it? The head goes at the top because that's just the way it is. Arms in the middle and legs at the bottom because that's just the way it is. And that's what I want you to think about when you start learning how to draw the different monomers for the biological molecules. You don't need to understand their structure, you just need to know what their structure is. And it is just a matter of accepting, like you did when you first started to learn to draw people, that the head goes at the top and the legs go at the bottom. Okay, so I've oversimplified it a little bit, but as I said before, amino acids, they're made up of the chemicals carbon, hydrogen, oxygen and nitrogen. And it really is just a matter of learning where the carbon goes, where the hydrogen goes, and the oxygen and the nitrogen. Like I say, you don't need to understand anything about the chemical bonds. You don't need to understand about electron structure the way you do in chemistry. For biology, it really is just a matter of where these different atoms are in relation to each other. So this is the diagram that you need to learn. I don't know how much you've probably already done at GCSE. Some of you might know this structure already. Okay, so here's one nitrogen atom. And the nitrogen is able to make 3 bonds with other atoms. And like I say, in terms of the chemistry and the chemical bonding that's happening, you don't need to understand any of the electron configuration here. So nitrogen is bound to 2 hydrogen on this side here and a carbon atom here. And then this central carbon atom is bound to hydrogen here and something else at the top. Now, if you know your periodic table, you'll know that there isn't a chemical symbol for any element, which is R, so we'll come back to this in a sec. Okay? And then we have another carbon atom on the end here, which is bound to an oxygen at the top and an OH group at the bottom here. Now, what you do need to know is a solid line like this represents a covalent bond. Now, if you do chemistry and you remember your chemistry from GCSE, you'll remember that this is where electrons are shared between atoms. You don't need to know that anymore for biology, AS level anyway. You just need to know that these are covalent bonds between the atoms. And up here, we've a bond between this carbon and this oxygen, but 2 lines is representing a double covalent bond there. Okay, so this is the structure that you need to learn. Now you might sometimes see an amino acid drawn like this instead. Okay, now there's nothing wrong with this. We've got the nitrogen and H2 representing the 2 hydrogen atoms. Instead of drawing the 2 covalent bonds go into the hydrogen atoms, we've just drawn H2 representing two hydrogens here. And on this side, instead of drawing the double bond going up to the oxygen here and the covalent bond to the OH group down here, we've just written COOH. This is a shorthand way of drawing an amino acid, and there's nothing wrong with drawing them like this in the exam. However, we really advise you to learn how to draw this version, because you need to know how amino acids are bonded together, and if you learn this structure, it'll be much easier to be able to show that reaction between two amino acids. If you learn this version, we find that students often make a lot of mistakes and drop marks in the exam that they wouldn't have had they learned the other structure. So this is how you'll see it drawn in your specification, but this is the version that we want you to learn. Okay. Now, when you draw an amino acid, it's always good to get into the habit of naming the different groups. So here, NH2, if you're a chemist, you probably already know that this is called an amine group. We can also call it an amino group. So this is the NH2 group at the end here. Okay, and on the other side, we have the carbon atom that's covalently bound with a double bond to the oxygen and to the OH group at the bottom here. Now, this is a carboxylic acid group, or a carboxyl group. Again, if you study chemistry, you might have already come across this. If not, you just, for biology, need to know the name. The COOH group is a carboxylic acid group, or a carboxyl group. Now, coming back to this group at the top here, R. Now, remember I said there's no chemical element with the symbol R. This just stands for the rest of the molecule. Now, with amino acids, there are 20 different types of amino acids, and it's this group at the top here that changes depending on the amino acid that we're looking at. So here's two examples here. Okay, so at the top, instead of R, we've got a hydrogen atom. So this now has converted the general structure of the amino acid into a specific amino acid. This one's called glycine, where we have H up at the top here. And down here, we've got the group CH3. So this is a different amino acid again. This is one called alanine. Now, it's just the R group that's changed in these two amino acids. And there are 20 different types of R groups that could possibly be bound to this central carbon, which gives us 20 different types of amino acids. Now, for your AS and A-level biology exam, you don't need to learn all of the different possibilities for the 20 amino acids that we can get. All you need to learn is this general structure. If you're ever asked to draw a specific amino acid, they'll always give you a table showing you the different possible R groups, and they'll ask you to just copy it from the table. So you don't need to learn them at all, although you do need to be aware that this R group at the top is the one that changes to give us different amino acids. Now, a protein isn't just one amino acid. We can have hundreds of amino acids all bound together, and it's the combination of amino acids, all of these different R groups, that give different proteins their different properties.